Hi everyone, welcome to lecture 18. In this lecture, I'm introducing sets in Python. We'll discuss set methods and set operations. So what are sets? Sets is essentially an unordered collection of distinct items. So this makes it different from a list or a string that we have discussed so far in this course. Uh, Unordered means that items are not stored in any particular order. Something is either in the set or not, but there is no notion of its position. For example, in a list we had the index and then the element. In this case, it's simply a collection of objects. And by distinct, I mean that that an item can appear in a set at most once. So there are no duplicates. This defines sets in Python. Now let's go and create sets and then talk about some methods and operations that work on sets. Okay, the way we create sets, and I'm calling this set 1, is by using the keyword set, and I created an empty set. I can also create a set, I'm calling it set 2, using these curly braces and then putting the elements inside it, 3, 6, maybe let's say 8, maybe even a string. You can have any object type as your element in a set, for example a floating point and so on. So this is my set 2. So I created 2 sets. I can also create a set, let's say I'm calling it set new, as set, and the range function works just like we used it with lists and with other object types, right? So 0 up to let's say 11 and step by 2, right? Let's go and print what set new has. Sorry, set underscore new has, and also check what set 2 has. So this is what my set looks like, as you can see on the right hand side in my console, right? Similarly, I can check what set 2 looks like. Set 2 is again all these elements, and as I said, their position does not matter, and that's because it's simply telling me that this set 2 is a collection of these elements put together. Now next I wanted to talk about some of the methods that work on sets, and the way to find out all the methods that work on any object type is to use this dir that tells you all the methods. For example, set 2 is of the type set. I can check what all methods are available. You'll get this entire list of all the methods that you can use on an object that's of the type set. We'll discuss some of these, not all of these. The first one is the add method. So we can update sets, and the way we do that is by using the dot add method, and this is different from list because in list we did dot append, right? So I can do set 1. Let's say set 1 does not have anything right now. I want to add some elements, and I wanted to add, let's say, 5. Set 1 dot add, and then let me check set 1 or print set 1, whatever you want, and you can see I got this element 5, right? Similarly, in set 2 I want to add something, and that something would be, let's say, element 6, and then go and print set 2 again. Now notice that I added a 6 and there was a 6 already there, and so it did not get added because by definition sets cannot have duplicates, which is why if I'm adding a duplicate by using the dot add method, it does not show up, right? The next method we are discussing, is the remove method. And one way of checking any of these methods, if you want to do that, and this is additional in addition to what we already know, is by using set2 dot remove, and I'm saying help. So basically tell me what this method does, and on the right hand side you will get everything that this method does. And notice that it says if the element that you're trying to remove is not there, it raises an exception. It raises an error. That means, for example, if I'm saying set2 dot remove, and in my set2 I have 6, right? So, and let's check what set2 has right now. So that's removed, right? Now if I go and run this again, this thing again, this raises an error because 6 is not there, right? It's not there, and I'm trying to remove it. So one way of handling it, and there are multiple ways of handling this, one is, and which is widely used, is to go and check if it's there and then go and do whatever you want to do. For example, I can say if 100 in set 2, I know 100 is not there, then only go and remove that 100. Otherwise, maybe do nothing, that's also fine. But like another way would be just go and say do something, right? Let's say print not found. It's up to you. But this is a way of dealing with this key error that was raised if that element wasn't there and if you're trying to use the dot remove method, right? So I'll say not found. Fine. There is another method that we use to remove elements in sets. For example, I can say set2 dot discard, and discard will not raise an error if that element is not found. It will discard that element, and if it's not found, it will not raise an error. So that's another way of dealing with this removal of elements. Okay, just like with lists, we can use len to get the cardinality, and we call cardinality here because there are no duplicates, to get the cardinality of sets, or in other words, to get the length or the number of elements in a set. Let me create a set. I'm calling it set 3, and then let me have some elements in it. Let's say 5, 7, 0, 1, 3. I don't know. This is enough. Let's go and create this, right? And then let me do an len of set 3, and then it will give me the number of elements, and obviously the number of elements is 5. Let me create a list, right? And we know how to do that. 3, 5, 7, 3, 4, 7, 0, and then this is my list. My len of v1, and we've done that, we've seen that before, is the length, that's 7, right? And now I want to create a set out of this v1. Let me call this set 4. I'm calling it set 4, and you can do this, and this is another way of getting or creating a set. I'm creating a set out of my list, and this is set 4, right? And then let me get the length of my set 4, and that length is 5, not 7. Reason being that I had repeated elements, for example 7 and then 3, and when I generated a set out of my list, it got updated to just 5 elements, right? So these are some of the methods that I wanted to talk about in sets. Now we move on to some set operations that are important from the mathematical side as well. Let's go and look at this picture. So this is basics from the set theory. This is what we'll talk about, and this is what we'll use. These are the operations that we'll use in Python to get the output. For example, if you have sets A and B, the union is the set of all elements. So essentially we'll be returning new sets, right? Intersection will return a set of only the common elements in A and B. Complement is everything but A or everything but B, depending on whose complement you're trying to find. And then symmetric difference is when two sets overlap, the element that's common is removed, right? So this will make more sense when we go and do that in Python. Let's do the set operations in Python. Let me begin with creating sets. S1 has some elements 4, 5, 6, 7, 8, and then S2 has some elements 3, 4, 5, 6, 8, 0, I don't know, whatever, and maybe a couple of more elements. So let's create these two sets. Now you know how to create sets. The first thing we are looking at is the difference. Difference means the elements that are in there in the first set but not in the other, right? And the way we do that is we are saying S1 minus S2. If both S1 and S2 are of the type set, then we'll get this difference as 7. So everything that's there in this minus whatever is there, if there is a match, just like get rid of those matches, whatever that is. For example, 4 and 5 were there and I said S1 minus S2. 4, 5, 6 and 8 were removed, just 7 remained, right? So this is what difference does. You can also write it as this and it will return the same result. That's difference. Now intersection, when we saw the picture, we saw intersection is the common elements, right? There are again two ways of doing that. S1 dot intersection, intersection S2 would give you the common elements in both the sets. So obviously they are 4, 5, 6, 8. Or a better and faster way is to just use this and sign, and that gives you the intersection. Now union. Union is all the elements but nothing is repeated. Get all the elements from both the sets but don't repeat anything is what union means. S1 dot union S2 is giving me all the elements, nothing is repeated. Alternate way of writing it is S1 S2, right? The other is the symmetric difference, everything but the common elements, right? So let's get that. It's S1 dot symmetric underscore difference S2. It'll give me everything but the common elements, as you can see in both of them. Or another way of writing it is S1 and then this and S2, and that would also give me the same result. Let's create this another set to know subset and superset, which means a subset is a set of elements that are all contained in my superset, is essentially what this means. For example, this would make things clear. Let me create this small set that has elements 0 and 1. This is my S3. And then I want to know if S3 dot is subset of S2, which essentially means are the elements of 0 like of S3 all there in S2 or not. It will return a true or a false. So it is true because 0 and 1 are there in S2, right? Another way of writing the same thing is by saying S3 less than equal to S2. This will also return a true or a false. Similarly, you could have said the other way is S2 dot is superset of S3, right? Like every element of S3 is contained in S2 or not. True, right? It's another way of writing this. Or you could say S2 greater than equal to S3, and then this should also return a true, right? Okay, a small thing about aliasing before we stop is, for example, I create this set that has some elements in it. Let's say it's G, I don't know, O, and then H, S. Let's create this set, right? I have this set as first, and if I create another set as second and I say first dot copy, what this does is second is a copy of first, and the changes in second are not reflected in the changes, for example, in the first set. What that means is second, if I do a second dot remove, and let's say I'm saying go and remove S, right? Okay, then let's see what happened to second. Second will not have S. What happened to first? Let's see what happened to first. It has that S, right? So if you really want those changes to be reflected, what you can do is create a third equals first. If you're saying this, then the changes in third dot remove S would be reflected in both first and third. Now you see S is removed, right? So here I'm creating an actual copy. Here I'm aliasing, so I'm actually referring to the same object, right? So this is the concept of aliasing in sets. With this, I end this lecture. In the next lecture, I'll talk about dictionaries. Thank you.